Unit 9, Lesson 3, Predicting Products of a Chemical Reaction. So there are certain steps we need to follow when writing and predicting a chemical reaction. We first need to identify the type of reaction first. So remember from Lesson 1, there are 5 types of chemical reactions. From there, we can predict the products using that type of reaction. Then we must balance the equation. Remember, there are 7 diatomic elements. They do make the actual number 7 on the periodic table, with the exception of hydrogen, because he doesn't follow any rules ever. Now, with a synthesis reaction, we have an element plus an element giving me a new compound. The idea is you have a plus side only on the reactant side. So, for example, if we wanted to write a balanced chemical equation for the reaction of sodium metal and chlorine gas, it would be sodium plus chlorine. They would come together to form sodium chloride. Then we would need to balance the equation. And to do so, we would put a 2 in front of the sodium chloride on the product side and a 2 in front of sodium on the reactant side. Got that? Now we'll go to decomposition reactions. Remember, the general formula is we have a compound that breaks down into 2 or more elements or compounds. Keep in mind, this is where the plus sign will occur only on the reactant side. Now, with decomposition, there are a few exceptions to the rules, and that's carbonates. They're a special case of a decomposition reaction that does not go to the elements. Basically, carbonates decompose to carbon dioxide and a metal oxide. And so here's an example. There are other special cases, but we're not going to go into those here. So write the balanced chemical equation for the decomposition of lead-4 oxide going to oxygen gas plus lead. Now, this is actually balanced as is, so we do not need coefficients. So now let's balance the chemical equation for the decomposition of barium carbonate. Remember, carbonate is our special case. So this will break down into carbon dioxide plus barium oxide. Now, this is also balanced as written, so we do not need to add coefficients. So remember, carbonates will break down into carbon dioxide plus the metal oxide. Now, combustion reactions, there are 2 forms. There's the hydrocarbon, which is basically a hydrogen and a carbon, plus oxygen to give me carbon dioxide and water. We can also have where it goes from an element plus oxygen to give me the element oxide. These here tend to also resemble combination reactions, and that is acceptable in the high school level to consider them combination and or combustion. Products of combustion are always carbon dioxide and water or an oxide. An oxide is basically where the element plus oxygen gives me the element oxide. So write the balanced chemical equation for the combustion of tricarbon octahydride. So here's tricarbon octahydride. It'll react with oxygen because you need oxygen for a fire. This will break down to give me carbon dioxide and water. Now, when it comes to balancing combustion reactions, these tend to be the most difficult only because we have oxygen occurring both here as 1 with the water molecule, but 2 here in the carbon dioxide molecule. So when it comes to balancing, this is going to be a trial and error as we go through. And here we have our hydrocarbon plus oxygen giving me carbon dioxide plus water. And when you are balancing, don't get worried when you have big coefficients. That is common when we have combustion reactions. So another one was sodium plus oxygen gives me sodium oxide. This is the one that was the exception that will sometimes resemble the single or the combination reaction or synthesis reaction. Now, due to my time restraints, I will come back with part 2 where we will talk about single replacement and double replacement reactions.